All right, you have been working with fractions since, I think, grade 2 or 3. But of course the rules have changed and upgraded as we've gone along. So I'd like to remind you where we're at in terms of knowing what to do with fractions. Okay, so once again, this is a no calculator question because everything we're doing could simply be typed onto the calculator. But we are looking for you to know what to do without the calculator. And it's actually a bit of an agenda because what we're going to do is we're going to stick algebra into fractions at some point this year, and we're going to need you to have all these skills for dealing with ordinary fractions that you're then going to apply to the guys that have x's and y's and a's and b's in them. Okay, so let's remember that when you add and you subtract fractions, it's going to happen when they have the same denominator. So let's say, for example, you've got 1 over 5, I'm going to use really basic examples just to jog your memory, plus 3 out of 5. Okay, the reason you can add these guys is because they have exactly the same denominator. Then you can just add the top, okay? And it would be exactly the same if it was subtracting. So you'd have 1 over 5, and then if I said minus 3 over 5. Let me actually show you what that looks like put into one fraction. It's actually 1 minus 3 over 5 because this sign gets attributed to the numerator. That might be something you haven't really thought about in that way before. Okay, but if I'm going to multiply, and I'm going to do multiplication and division separately because they're actually the same thing, but there's an extra step with division. I'm hoping you're thinking about what that step is because you have done this before. And if you can get a few steps ahead of me in terms of your thinking while watching the video, that's also a good thing. What if I said 1 over 5 times 3 over 5? Just a reminder then that even though they have the same denominator, you're just going to multiply the top by the top and the bottom by the bottom. Okay, and then what if it was divide? If it was divide, then I would have 1 over 5 divided by 3 over 5. And I want you to remember tip and times. That's when we do dividing. Okay, so that's actually the same as 1 over 5 times 5 over 3. You only tip and times the thing that comes after the divide sign. And that one's really easy because I'm going to cancel any top with any bottom, and I'm going to end up with 1 over 3. Okay, if I had multiplied at this point, I would have had 1 times 5 is 5, 5 times 3 is 15, I would have had 5 over 15, and then I would have cancelled the 5 with the 15 and gotten 1 over 3. Okay, so what happens if you do not have the same denominator? Well, you need to get it to the same denominator. You need to find an LCD before you can add and subtract. Okay, then a little reminder about what these signs mean. I want to just add some teeth. I call them crocodiles because the crocodiles only eat once a year, right? And that means that they will always eat the biggest thing they can possibly find. Well, that's my kitschy little way of remembering what to do. So we must remember that a crocodile will eat the bigger one. So if I do it in this way, and I have an x here and a y here, I'm saying that x is the small one and y is the bigger one. So we refer to this as the less than. And we actually use less than more than we use greater than because we like to put numbers in order of their size. So we always put the smaller one on the left, we put the less than sign, and put the greater one on the right. This one, if we put here, I'm going to put the y on this side because we decided the y was bigger. It means that y is greater than x. Okay. And then just something on the side that I'd like to let you know about that could be useful. If we say greater than 0, we actually mean a positive number. And if we say less than 0, we actually mean a negative. And that's often used and often confuses people. Okay, let us do some examples of adding and subtracting and dividing and timesing fractions that have no variables in them. Right, so the first example we have a denominator of 3, of 2, and of 8. Okay, so they do not have the same denominator, which means I need to find an LCD. Okay, so what I'm going to do is I'm going to start with the 8. So I'm going to say 8. Do 3 and 2 go into 8? No. What about 16? Does 3 go into 16? No. 2 does, but it doesn't matter. I need to find an LCD for all 3. Okay, so not 16. 8 times 3 is 24. Does 3 go into 24? Yes. Does 2 go into 24? Yes. And we just established that 8 already did. Okay, so my LCD is going to be 24, and you actually get a mark for knowing that, for knowing what the LCD needs to be. I have a habit of always putting a big fraction when I find my LCD, just to make a really clear notification for myself on the paper that I've now got there. I've gotten the LCD. I don't go and rewrite them as something over 24, something over 24, something over 24, not when it is just normal numbers like this. Okay, but if you want to separate them out and put 3 different fractions, each over 24, that's fine too. Okay, so a reminder here, I have to times 3 by 8, so that means I need to multiply 2 by 8. Okay, so 2 times 8 is 16. Then I'm going to add, what about 5 over 2? 2 must multiply by 12, so I multiply by 12 over 12, and 5 times 12 is 60. Note that I'm copying and pasting the signs, okay, even though I'm now obscuring them with my writing. 8 I have to multiply by 3, so 1 gets multiplied by 3 as well. Okay, so 16 plus 60 minus 3 gives me 73 over 24. A lot of grade 9s will ask me at this point, should I go and change this into a mixed number? And I'm going to say, don't. Okay, unless there's a really compelling reason, because it's such a waste of time and it's not what we're testing in this section. Don't change to mixed number. Okay, randomly. Wait for there to be a good reason, like if I wanted to know, how many packets of crisps that was. And then you had to tell me, well, it's, something 1.5 or a number like that. Okay, but there's no need to change it. This is an abstract question. There's nothing practical in it, and you don't need to go and change it. Okay, right, here we have mixed numbers. Okay, you'll probably learn through this video that I'm not a fan of mixed numbers. I find them really useless. And what you can do is you can convert using your mixed number button. If you look at your calculator, it is a function where you can type it in, and you can second function your S to D button, and you can change from a mixed number into a improper fraction. Okay, and if you do that step on the calculator, we won't know that you're using a calculator. So I'm not contradicting myself. You can't use a calculator for all of the steps, but if you do tiny little baby steps on the calculator that we can't figure out, you are welcome to play the system, in my opinion. Okay, be careful with your typing, all right, when you are checking this answer, because of course you can use a calculator to check each of these answers. All right, I need to convert. 3 times 3 is 9, plus 1 is 10, and the denominator stays the same. Okay. 4 times 5 is 20, plus 2 is 22, and the denominator stays the same. And now we're back in the position of question A, when we have a problem because we don't have the same denominator. So let's start with the highest one and go up in multiples of 5. Does 3 go into 5? No. 10? No. 15? Yes. Okay, so I'm going to then establish my LCD. It's going to be over 15. And I'm going to times this guy by 5 over 5. 10 times 5 is 50. Copy and paste my sign, which is a minus. And this I have to multiply by 3. And again, if you can't see 22 times 3 in your head, no problem. Do that on the calculator because I'm never going to know. It is 66. And then if you are not sure about integers, you could even do that baby step on the calculator. But can you see what I'm doing here is I'm taking on the burden of proof to show that I haven't gone and done all the important steps on the calculator. This is going to be negative 16 over 15. And again, absolutely no need to convert to a mixed number. For question C, I've also got mixed numbers that I need to deal with here. Okay, so if you're going to convert in the calculator, just make sure that you type it in correctly and you don't go and type in -1 times 2/3. You must use the proper button. Okay, right, so that is 3 times 1. Please note that I am ignoring the negative for now because I know the answer is going to be negative. 3 times 1 is 3, plus 2 is 5 over 3. Where do I put the negative? On the top. Okay, we always move negatives in fractions to the top. It's just much easier to work with that way. Okay, I've got to times that by -1/2. You see, they've put the negative there in the middle. It's not incorrect, it's just much more useful to put it at the top. So have that as a way of working with fractions for yourself. Okay, divide by 4/7. No, I am going to times by 7/4, and I'll always do that. I write a question out as a tip and times when I see a divide. It's just an automatic reflex. Okay, now I'm going to think about tops and bottoms cancelling. And I'm also going to remember that LCD is not a thing because this is times and divide. Okay, which ultimately becomes a whole bunch of times because divide just becomes times anyway. And I can times through all the numerators and all the denominators if nothing cancels, and unfortunately nothing does. So it's not like I can cancel there. Nothing cancels, no tops and bottoms cancel. Okay, so let me just think. Negative times a negative is a positive, times another positive is a positive. Okay, there's also an even number of negative signs in this question, so my answer is going to be positive. You know what, I'm just going to put a plus down just to like notify myself that I've actually done that bit. Okay, 5 times 1 times 7 is 35 times table. Okay, and on the bottom, 3 times 2 is 6, times 4 is 24. And that is my answer. Again, not converting to mixed number. Just a little tip on looking at fractions. Please note that I am using double lines to write fractions. I'm making them really, really big, and you would be advised to do the same when you are writing things in a workbook, because otherwise if you try and squish it all into a line, you'll find that it's difficult for someone else to read. And ultimately what you are doing as a student of mathematics is you are communicating your understanding with another human being, which means you don't have to have pretty handwriting, but it definitely needs to be clear. And when we're cancelling and we're drawing all over the place, we're doing funny timeses like that, it all gets really messy. And so the bigger you write, the clearer it is for someone else to understand that you know what you're doing.